This is the screencast for section 3.1, example 6, logistic functions and their graphs. Logistic functions, or we will be dealing mostly with logistic growth functions, take on this form. F of x equals c, which by definition is our limit to growth, which literally means the function will not grow past that value. And then all over 1 plus a times b to the x, where a and b are positive constants, so they can be decimals, fractions, whole numbers, it doesn't matter. Or we could see this as the form, since b to the x can be written as e to the negative k times x, we might see it in this form as well. Or even simpler, we might see it as this form down here. So we have three different ways that we might see a logistic growth function. We're mostly going to be dealing with these two forms up here. And then just in case you're wondering, a logistic decay function does exist. That's when b is greater than 1. Weird, right? B has to be less than 1 to be growth, but b is greater than 1 in order to be decay. Kind of the opposite of exponential functions. Logistic functions, a growth function, the b value is less than 1, and a decay function would be greater than 1. Well, let's look at an example. Example 6 says, graph the function. Find the y-intercept and the horizontal asymptotes. Done. Here is my y equals. I found a good window so that my window can show the actual growth happening as well as the function reaching the lower horizontal asymptote and the upper horizontal asymptote. That's right. This function will have two horizontal asymptotes, one for the left side of the function and another one for the right side of the function. So in this case, the two horizontal asymptotes are y equals 0 and y equals the limit to growth, 8. So those are the horizontal asymptotes. So that means this function will grow from 0 all the way up to 8, but never actually hit 8. Then let's see, the y-intercept, if I plug in 0 for x, I could find that by hand. 0.7 to the 0 is 1, and then 8 divided by 1 plus 3 times 1, so 8 divided by 4 would be 2. So the y-intercept is 0, 2. I'm going to check that. Yeah, it is. So the y-intercept is 0, 2. And if you remember, that's also called the initial value. Exponential growth and decay, the initial value is the number in front of the base. That is not the case here. You have to plug in 0 for x in order to find the initial value. That's what the definition of initial value is, the y-intercept, when x equals 0. Now let's look at part B. Part B, I also found a window that demonstrates a good viewing of the lower horizontal asymptote and the upper horizontal asymptote, as well as the growth from one to the next. As I said earlier, there are three different forms of logistic functions, and the first one was in that a times b to the x. This one is in the e to the negative k times x. This is how you memorized your basic function back in section 1.3 from those flashcards that I gave you. So this is also another form of logistic growth that we will be dealing with. The the base has a negative exponent, which makes it less than 1, which as described earlier makes this a logistic growth function. The two horizontal asymptotes are y equals 0 and our limit to growth, y equals 20. The y-intercept for this one, is that as easy as it was before? Let's see, if I plug in 0, and then e to the 0 would be 1, so then I have just 2 over here. 1 plus 2 is 3, so it would be 20 thirds. 0, 20 thirds, which I think is 6 2/3. Yeah, it even came out of my calculator as 20 thirds. Cool. Which again is also the initial value. The now try problem for example 6 is number 41. You can see right off the bat that I've got a limit to growth of 12. My base value down here in the bottom is definitely less than 1, so I can tell you this is logistic growth. I can also tell you that the horizontal asymptotes are going to be y equals 0 and y equals 12. I did the graph already, so there's your lower horizontal asymptote, here's your upper horizontal asymptote, or your limit to growth. The y-intercept I can see is about 1, 2, 3, maybe about 4. So let's see, if I plug in 0 for x, 0.8 to the 0 is 1, 2 times 1 is 2, so I really have 3 in the denominator. 12 divided by 3 is 4, so the y-intercept is 0, 4. Double check that with my calculator. Yep, 0, 4.